We have an AC circuit. It's an RLC series circuit with just a resistor and an inductor. We're given the RMS voltage and the RMS current, so let's start there and find the impedance. Okay, so our Ohm's law for this kind of circuit goes like that, and the impedance is therefore the RMS voltage, which is 45 volts, divided by the RMS current, so that's 300 ohms. Alright, now in this case, since we just have a resistor and an inductor, we can write the impedance like this. So that's 300 squared. Now the resistance is given to be 32. So if we solve for x sub L, we get x sub L is 298 ohms. And we set that equal to 2 pi FL, then L is 298 over 2 pi times the frequency, which is 60. And that's 0.79 henries. Right, so there's your part A. For part B, we want to know the maximum value of the voltage drop across the resistor. Well, we just need the maximum current. That's the square root of 2 times the RMS value. So that's 0.212 amps. And the maximum value of the voltage drop across the resistor is simply the maximum current times that resistance. So 0.212 times our resistance of 32 gives us 6.8 ohms, or 6.8 volts, sorry. Part C, maximum value of the voltage drop across the inductor. Well, voltage drop across the inductor, that max value is just I max times the inductive reactance, which we know up here is 298. So if I multiply those, I get 63 volts. Alright, part D. What's going on when the current is equal to 0? Okay, well, when the current is equal to 0, then the voltage drop across the resistor is 0 because the current is in phase with the resistor. Right, that is, the voltage drop across the resistor always matches whatever the current is doing. So the voltage drop across the resistor is 0. Now, what about the voltage drop across the inductor? Well, remember that in this case, the current looks like this, right? Here's the current versus time. And I guess the current is varying, you know, with like a sine or a cosine. It doesn't really matter in this case. So let's say that the current looks like that over time, okay? Well, when the current is 0, here, 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 and here, right, when I is equal to 0, the slope of this graph, delta I over delta t, is the maximum value. That's maximized, right? And that's what delta VL goes by, right? The EMF, the voltage drop across the inductor, goes as L delta I over delta t. And so that means delta VL is max. Okay, so at this time, delta VL is whatever that max value is up here, 63 volts. Alright, and then finally, the loop rule tells us that the voltage drop across the source is equal to the voltage drop across the resistor plus the voltage drop across the inductor. The loop rule works at any specific time. And so at this specific time, it's 0 plus 63, so the voltage drop across the EMF is 63 volts. Right, now you can't use the loop rule here. Like, I couldn't say that the voltage drop across the resistor is 69.8 volts or whatever, because these two voltage drops, these two maximum voltage drops, do not occur simultaneously, right? This one occurs when the current is maximized, and this one occurs when the current is 0. So you can't use the loop rule with these. They occur at different times. But we can use the loop rule down here because it occurs at a specific time when the current is equal to 0.